All right, guys, so I recorded a 24-minute video for you earlier and I lost it. It did error uploading and I couldn't find it on the iPad, and this happens at school sometimes. So I'm pretty frustrated. So I'm going to make this very quick. Basically I didn't remember all the things I said, but I basically went over this with you guys here, and I'm going to do it again really fast. The 2006 that's due today, 1, 2, and 4. I do want to try and do a Google Meet tomorrow at 9. I'll send an invite out. I'll text again. Hopefully more of you respond. I hope you're doing all right with the multiple choice. I might make that due Friday because of all the problems. I also want to give you some free response in the classroom on Unit 7, maybe due Monday. I know you got a lot of work. You're probably getting slammed by all the teachers because everyone wants to feel like they're doing the best they can. Students, I hope, teachers, I think teachers, we have an innate, I gotta get work out. I gotta do my job. I gotta help them learn. And, I feel that a little bit, but it's tough. We're all trying to figure this out. And, it's a tough situation, and working from home is not the easiest thing for some of us. So anyways, I get all that. Just feel free, text me, email me, communicate through the cloud, whatever you need. I'll help you the best I can. So I understand things are not easy, but anyways, we're doing the best we can. What else did I want to tell you? Those review classes, AP Live, I sent that link, every day, 1 to 1:45. I think it was every day, or every Thursday. I forget. I just did a whole bunch of stuff here, so I'm like fried a little bit. What else? Oh, I wanted to go over this. Real quick. That's not it. This question. So this I went over, again, earlier in that video I lost. So there's an equation you can use to figure this out. This was the one where it was 4,000 megawatts. And, 4,000 megawatts. Basically, you have to take the 3.5% increase and calculate how 200,000 grows in 40 years, and then multiply it by the megawatts per person. And yeah, I make it sound easy. I realize that. The equation, and it's on page 206 in your textbook. Right here, page 206 here, exponential growth. Hopefully that came in there. So it's n sub t equals n sub 0 times ERT. And this is the exponential growth part. This is your end population. Our starting was 2,000. That's a 0. E, so times E. The rate is percent, 0.035 times 40 years. So when you do this, you get like 4.055, I think. And I kind of walked you through it in my other video. I just honestly need to get upstairs and relieve my wife. She needs to do her work. So I'm trying to do 2 videos in the time of 1 here. So multiply these together, you get roughly 811,000. So for this problem here, again, that equation, how would you know that on the test? I didn't tell you that. I guess that's my bad on that. No, I guess it is. Do I think you need to know this for the AP test? I don't know. I'll be honest. From what I'm looking at, no one really says that anywhere. Nothing says that. But that's an exponential growth equation that works for any exponential growth as long as they give you the percentage and the time frame, and then you have the initial. You can always figure out the end result. So anyways, that's how, some of you were asking me, how do we do this? And I never got back to you on this. So that's how we do this problem, 811,000 per capita. So 5 kilowatts. 5 kilowatts is the same thing as 0.005 megawatts. You do need to know that. I gave you those math sheets. I'll talk more about them tomorrow, some other time. I am going to give you math work next week. I know you have a lot going on. I'm sure you do. But, I think the math is good practice. So some of it is just this, right? This is that, and then this is that, right? So mega is 10 to the 6th, kilo is 10 to the 3rd. That's something you need to know going into the AP test. So a kilowatt and a megawatt, there you go. So you take that 81100 times 0.005 megawatts, and you get roughly 4,000 megawatts. And that's why the answer was D. All right. Real quick, here we go. This is why I have the video. Where am I? 5.5 minutes. All right, here we go. Okay, quick. So number 1, and you can find these answers online. I just use free response from the AP college website. This isn't secure stuff for teachers only. You can go on, you can find these, you can look up the answers, but ideally you would do what I assign and then wait for me to go over it like this, because I throw in my 2 cents and stuff like that. Obviously, you know, it's why I get paid the big bucks to be a teacher. You know, you can look these up, obviously, but I think it's better hearing it from me and talking about it. I don't know. I think that's better. And I don't mean that in an arrogant way. I just think that's the whole point of school, right? So, anyways, here we go. Most diseases don't drive host to extinction. Why? Genetic diversity. Some will be resistant naturally. That was the first thing I thought of when I read that question. Sometimes the organisms can co-evolve and the host will adapt and resist that disease. If the host goes extinct, then the disease or pathogen goes extinct too, right? So that doesn't usually work out too well for the pathogen. And then initial death. So if the population drops dramatically immediately, very quickly, there's such a small population left, the disease can't really spread. So therefore, some of them will get through it. 2 threats other than white nose syndrome to the survival of bat species. They'll have trouble finding mates because there's not a lot left. Competition from other species that have a similar niche. So other organisms that compete with the brown bat might overpower them because now there's not enough brown bats. The genetic diversity will definitely decrease, like we learned with the cheetahs. That's a problem because the gene pool is small, so they're all going to be mating. It's just a small gene pool to mate. So there's not enough diversity. Because the decreased protection by the group, there's not going to be enough to create heat, less protection from predators, let's say. Okay, brown bat does not become extinct. Why would it be slow? The biggest thing here is it has a few babies per year and a lot of parental care. Now, the article talked about, these are just the answers. The article talked about just a couple babies, or pups they call them, right? So there you go. If you only have a couple babies per year, you know, we're not talking about like rabbits or mice here, it's going to take longer for them to recover. Bats are found in ecosystem 2 ways in which other organisms could be affected. There's going to be an increase in whatever the bat eats. That could be insects, so that could increase diseases. The fungus, the white nose syndrome would decrease, right? Because there's less bats. Less bat guano poop. Plants that rely on pollination from bats could decline. Predators might die off because they have less prey, the bats. Trophic cascade. I think a Jenga. You take out one piece and the whole thing could fall down. So bats are part of a trophic pyramid or trophic levels, part of an ecosystem, you know, much bigger picture, food web, right? And that you take one piece out, the rest could kind of crumble, or at least be, you know, hurt. The eastern deciduous brown 2 ecosystem and forests provide and a benefit to human society. Resources, building and lumber, fuel, food, oxygen, so we can breathe. It takes CO2 out of the atmosphere. Biodiversity is a big one. It protects water sources, drinking water. There's the aesthetics. There's that. I know I'm going fast here. I have to. Provided likely reason in emergency, good aspiration. So basically it's saying the increase in emerging infectious diseases, which is sadly very appropriate right now. And the first thing I thought of was overpopulation and people, you know, what decisions people make. You know, so if we have global warming, diseases can spread much better in warm, wet places than cold and dry. A lot more people, so more people mixing, global traveling. That's why New York and New York City specifically is getting hammered with this, is my opinion. I don't know for sure, but there's so many people there and from different parts of the world that they maybe just traveled from. It's just a lot going on in the city, so, a lot of mixing. Let's see, lack of vaccinations. We don't have one right now for the coronavirus, as an example. And the more antibiotics we use, the more resistant they become. That's not applicable now. We're talking about a virus, not bacteria, but that's still a pathogen. And then decrease in medical care, poverty, war, migration, human behavior, refusing condoms, sharing needles, refusing aid. Okay. All right, this was, let's see, what do I got for time here? All right. I'm going to stop. Actually, I'm keeping these videos